Atoms, Elements and Compounds, GCSE, iGCSE and General Chemistry.
Chemistry Explained are chemistry lessons designed for you to participate in. So make sure that you are writing notes and completing tasks on paper or on tablet. Move through the lesson at the pace that suits you. Skip ahead or move back as you wish. Most importantly, when prompted, pause the lesson, complete the task, but taking your time and thinking the problem through. Resume and check and correct your answers before moving on.
All of the ideas listed here are fundamental to GCSE, iGCSE and any general chemistry courses. I'll start with the concept, of course, of atoms and elements. We'll go through compounds and formulae, the idea of the molecule, naming compounds, and then simple word equations. The simplest idea of an atom is that it is the smallest possible particle of an element. Now, the radius of an atom is measured in nanometers. That is, they are very, very small. So 1 billion nanometers make up 1 meter. If that is the case, could you express the nanometer in a value of meters? Pause. Write down the value of a nanometer in meters. Okay, so have you written 1 divided by 1 billion? If you have you written it in standard form? If not, pause. Can you write it in standard form? Okay, so here is the nanometer, 1 billionth of a meter in standard form, 1 times 10 to the minus 9. The radius of an atom is actually closer to 0.1 nanometers. Could you express 0.1 nanometers in meters? Pause. Come back to check against my answer. Okay, so 1 times 10 to the minus 10. 1 times 10 to the minus 9 divided by 10 is 1 times 10 to the minus 10 meters. We'll move on to looking at elements, which we will just define as substances containing only one type of atom. So elements contain only one type of atom. Atoms are the smallest particle of an element. These are mutually inclusive definitions. To define an element, we need to think of atoms or define atoms, and to define atoms, of course, we need the idea of the element. So atoms are the smallest particle of an element. Elements contain only one type of atom. However, the structures in which we find those atoms can vary. We can have single atoms, giant arrangements of many atoms, or molecules, which we will define more closely in a following lesson, following slide. We can take single atoms such as helium, giant arrangements such as the atoms in sodium, or as a molecule, the atoms of sulfur linked into a ring of 8 sulfurs. Now, each of these are elements in that they contain one type of atom. Sulfur has one type of atom. Sodium, one type of atom. Helium, one type of atom. They are all elements. There are 100 known elements as listed in the periodic table. I'm sure you're familiar with the periodic table. For instance, hydrogen is an element, sodium is an element, sulfur, argon. Each element is given a unique symbol. So each type of atom is given a unique symbol. For instance, capital H for hydrogen, sodium, capital N, lowercase a, sulfur, capital S, argon, capital A, lowercase r. Please notice each symbol starts with a capital letter. The second letter, if there is one, is in the lower case. So a straightforward exercise using the periodic table. Complete this table. We want the element symbol if it's missing, or the element name if that is missing. Pause, complete the table, come back to check against the correct answers. Okay, so capital H for hydrogen, Na is sodium, potassium, capital K, magnesium, 2 letters, capital M, lowercase g. Carbon, capital C, chlorine, capital C, lowercase l. Fe, iron. Compounds and formulae. Compounds and formulae. Compounds are composed of 2 or more different elements that are chemically combined. That is, they are bonded together, joined in some way. So, for instance, if we look at a compound such as copper oxide, we know that the elements combined are copper and oxygen. Pause and complete the element combinations for calcium chloride and sodium hydroxide. Come back when you're ready. Okay, so obviously calcium and chlorine, not so obviously sodium, hydrogen and oxygen, more than 1, 2 or more. So in this case, 3. Now, compounds are formed by chemical reactions. So we have to distinguish between compounds and mixtures. Formation of compounds usually is accompanied by the release of heat energy. So calcium and chlorine going to form calcium chloride. That reaction would release some heat. We've formed the compound, and the compound cannot be easily converted back into its elements. The formula of a compound is always the same. Calcium chloride is always 1 calcium, Ca, and 2 chlorines, Cl2. So 1 calcium and 2 chlorines. No matter the reaction in which it forms. So the direct combination of calcium and chlorine to make calcium chloride, the formula CaCl2, 1 calcium and 2 chlorines. If I make calcium chloride by the neutralization reaction between calcium oxide and hydrochloric acid, making calcium chloride and water, the formula of calcium chloride is CaCl2. Elements in a compound combine in a fixed ratio. That is, the formula is always the same, regardless of the chemical reaction in which it appears. So, interpreting a compound formula, as I did on the previous slide, involves, first of all, identifying the element by its symbol and then the number of those atoms in the compound. So hydrogen here appears, as does oxygen, but the subscript 2 only applies to the hydrogen. So if we write the formula, we've got 1 oxygen but 2 hydrogens. So that small subscript 2 only applies to the hydrogen. We only have 1 oxygen. So wherever we encounter water, the formula of water will always be H2O. That is 2 hydrogen atoms for every 1 oxygen atom in the compound. So if we look at carbon dioxide, we see we have essential carbon and oxygens left and right. The formula for carbon dioxide would be 1 carbon and 2 oxygens, CO2. And this is always the case for carbon dioxide. The formula is always 1 carbon and 2 oxygens, CO2. Now try this exercise in interpretation of formulae. So I've done the first one as a model. H2SO4, that's hydrogen sulfate or sulfuric acid. We've got 2 hydrogens, so I write 2 times hydrogen. Second element is capital S, so that is sulfur. There is only 1 of those. Capital O, so that is oxygen, and there are 4 oxygens, so I write 4 times oxygen. Could you complete the table for the remaining 3 compound formulae? Pause, come back to check your answers. Okay, so MgCO3, magnesium carbonate, we have 1 magnesium, 1 carbon, and 3 oxygens. Lithium oxide, 2 lithiums and 1 oxygen. And then there's a slight complication with the last one. You will see in compound formulae the use of a bracket. Well, we can use the same idea from mathematics, that everything inside the bracket is multiplied by the 2. So although we have 1 magnesium, it is outside of the bracket. Everything inside the bracket, oxygen, is multiplied by 2 oxygens. Everything inside the bracket, hydrogen, is multiplied by 2. We have 2 hydrogens. So that is how to interpret formulae including a bracket. Everything inside the bracket is multiplied by the subscript number outside the bracket. Review question. If each coloured circle represents a type of atom, which of the boxes A, B, C or D contain elements? Pause. Come back when you have your answers. Okay, so A is an element. It contains 1 type of atom. B is not an element. There are more than 1 type of atom involved. C is not an element. D has only 1 type of atom. So A and D are elements containing only 1 type of atom. Let's look at the idea of the molecule. Molecule is the name given to a particle of more than 1 atom bonded together. So molecules may be of 1 type of atom only, that is an element molecule. For instance, sulfur forms molecules with 8 sulfur atoms. It is an element, it's got 1 type of atom, yet there are 8 atoms, and we call that particle a molecule. Hydrogen forms molecules with 2 hydrogen atoms. Again, it's an element, 1 type of atom, but 2 atoms joined together, more than 1 atom bonded together. So it's a hydrogen molecule. We can also apply the idea to compounds. So carbon dioxide contains carbon and oxygen, so it's more than 1 type of atom. And we have a molecule of carbon dioxide, 1 carbon bonded to 2 oxygens. So that's a molecule of carbon dioxide. So we can apply molecule to compounds and to elements. So a simple problem. Which of the following boxes represents a molecule or contains molecules, bearing in mind each coloured circle represents a type of atom? Pause, make your choices, come back when you're ready. Okay, so let's start on the right-hand side. We've got more than 1 atom joined together or bonded together to form a particle. Those are molecules. So D contains molecules. C, also more than one atom combined to form a particle. They are also molecules, although of course D is an element molecule and C is a compound molecule, as is B. B is also a compound molecule. At GCSE, we might regard A as atoms rather than molecules. Naming compounds. Let's start with an example. A simple binary compound, that is a combination of just two elements. Let's take element 1, sodium, element 2, chlorine. For the name, you simply list the elements left to right as they appear in the periodic table. And the second element name changes its ending to "ide". So for instance, sodium and chlorine, we have sodium chloride. Sodium is to the left of chlorine in the periodic table. Chlorine is to the right. So we have sodium followed by chlorine, but we change the ending to "ide" to indicate that it is a compound. So this pattern is very easily followed. So pause the lesson and complete the compound name for 1, 2, 3, 4, 5 examples here. So element 1, calcium, element 2, chlorine. What's the compound name? Complete for all 5. Come back when you are ready. Okay, so if I reveal calcium chloride, make sure you've got the ending. Magnesium oxide. Make sure you've got the remaining 3 correct before I reveal. Silver sulfide. This is very often written down as silver sulfate. That's a different compound entirely. Silver and sulfur, silver sulfide for this simple binary compound. Sodium iodide and tin bromide. And of course, we can derive the compound name from the compound formula. So if we look at these 5 examples, we've got magnesium and nitrogen. So what would be the compound name? Complete for all 5. Come back to check against my answers when you are ready. Okay, so I'm going to reveal magnesium nitride. So nitrogen becomes nitride. Calcium and sulfur, calcium sulfide. Lithium and chlorine, lithium chloride. Sodium and oxygen, sodium oxide, and potassium and bromine, potassium bromide. Please note, the compound name does not include information about the numbers of sodium atoms, for instance, or the numbers of magnesium relative to the numbers of nitrogen. The compound name does not have as much information, obviously, as the compound formula. However, in combinations of non-metals, the number of atoms of an element in the formula may be indicated in the name. There are some very common examples of this which you will be aware of. For instance, CO2, you will know as carbon dioxide. So we've got 1 carbon and 2 oxygens indicated by the di. You may have heard of carbon monoxide, 1 carbon, 1 oxygen. So mono indicates 1 oxygen for each carbon. So we have mono and di. Would you like to try the remaining 4? Write down your answers and come back to check against mine when you are ready. Okay, so sulfur dioxide, 2 oxygens to 1 sulfur. Sulfur trioxide, there are 3 oxygens to 1 sulfur. This is a monoxide, nitrogen monoxide, and returning to nitrogen dioxide. Sometimes a group of atoms will go through a series of chemical reactions and remain as that group intact. So these common groups of atoms have got some common names. So you possibly will recognize them from formulae you are familiar with. The OH group, that is known as the hydroxide. Sulfur and 4 oxygens, SO4, is sulfate. NO3 in a compound is known as nitrate. And CO3, 1 carbon, 3 oxygens, is known as carbonate. NH4, that's 1 nitrogen and 4 hydrogens, is known as the ammonium group. So these group names, hydroxide, nitrate, carbonate, sulfate, are retained in the compounds they form. So these group names apply to the compounds in which they appear. For instance, NaOH, we have an OH group, so that would imply the hydroxide. So the name would be sodium hydroxide. If we look at the next example, CuSO4, we've got SO4. Well, that's a group that hopefully you will recognize. So we would call that copper sulfate. That is, the SO4 is named as sulfate. The OH is named as hydroxide. KNO3 contains the NO3 group, so that is potassium nitrate. Calcium carbonate contains the CO3 carbonate group, and ammonium chloride, because the NH4 group there is to be recognized. So OH is hydroxide. SO4 in a compound is named as sulfate. NO3 in compounds, nitrate. CO3 carbonate. NH4 ammonium. So let's name these compounds, which are all contain the reactive groups mentioned on the previous slides, which you may see in some textbooks referred to as radicals. So, compound formula, Na2CO3. What's the compound name? There are 10 examples there for you to try. Pause, come back when you're done. Okay, so looking at my answers, sodium carbonate, we have the CO3 group carbonate, sodium carbonate. We've got the OH hydroxide, so that is copper hydroxide. We have SO4, so magnesium sulfate. NO3 is of course nitrate, so that's calcium nitrate. We have both hydroxide on the right-hand side, and on the left-hand side we have NH4 ammonium, so this is ammonium hydroxide. Below, ammonium bromide. Sodium on the left and NO3 nitrate on the right, so sodium nitrate. Zinc carbonate, CO3 is the carbonate group. And finally, K2, which is potassium, SO4, potassium sulfate. Word equations. Word equations are ways of describing chemical reactions using the element and compound names. For instance, the reaction between calcium and chlorine to form calcium chloride. Can you put that into a word equation? Pause, come back to look at mine in a moment. So calcium and chlorine, get the name of the compound right, calcium chloride. That is a word equation. Write a word equation for the reaction between sodium bromide and chlorine to form sodium chloride and bromine. Pause, write that word equation, come back to check against mine. So to reveal, we have sodium bromide and chlorine, those are our two reactants, forming our products sodium chloride and bromine. So to finish, here are 4 incomplete word equations. Can you identify the missing substance name? Pause, take your time, think it through, come back to check your answers when you're ready. Okay, so magnesium and hydrogen sulfate produce hydrogen, so this is chemical change, so this shows there is a chemical reaction. Magnesium and hydrogen sulfate go to form hydrogen, and we keep the sulfate as a group, so we're left with magnesium sulfate. The second one, zinc, and the missing compound goes to form zinc oxide and copper. Well, we must have copper in that compound and we must have oxygen, so we deduce that the missing compound is copper oxide. The third one, copper sulfate and zinc, gives us copper. Well, the sulfate will stay as a reactive group, but it will be as part of a zinc compound. So copper sulfate and zinc forms copper and zinc sulfate. And finally, an element plus sodium iodide is going to give us iodine and sodium chloride. Well, I hope it's obvious. We have the element chlorine. So rather than recommending you moving on to a new set of questions or textbook, I would say that if you had any difficulties with the naming of compounds, for instance, I would repeat the lesson. It is about repetition until you become entirely secure with recognizing the carbonate, the sulfate, etc. After that, please move on to one of my other lessons. Please subscribe, please like.